Okay, guys, we're going to do two more constructions with patty paper. I need you to do finish part B, the constructions that we're going to do with part B with your patty paper. The first one we're going to do is we're going to trace our triangle here, ABC. So let's get that traced. I'm also going to make sure I label the vertices so I can see it. Mine is a little off here. Let's fix that. So C, B, and A. Alright, so for our construction here and our discovery and observation that we're going to do is we're going to do median. So a median is just going to go through the midpoint. So I'm not going to all the way fold it, a crease, like a whole line. I'm just going to find the midpoint of each side. And if I want to get the midpoint of each side, I'm going to move this for right now. If I want to get the midpoint of each side, I'm now just going to have to do what we did on our equilateral and our isosceles properties investigation. We're going to just fold so that the vertices, the corners, coincide, and I'm just going to pinch right here, just pinch, and then open it up, and I can see a little crease, and I'm going to recognize that as the midpoint. I'm going to put a point there. Let's go ahead and put that one as M. And to draw a median, we're going to go from the midpoint of a side to the opposite vertex. The opposite vertex here is B. So we need to draw a line segment from the midpoint to B, like such. And now we're going to do this for each side. So we did the midpoint of AC. We're going to do the same thing for AB. I'm going to fold it over, just kind of roll it around here. Make sure A is on B. Kind of pinch it right there so I can see the crease. There's my midpoint. Let's label this one O. And then we're going to connect from the midpoint to the opposite vertex, which is C, like such. And we're going to do the same thing for BC. So I'm going to just, want the corners, the vertices to line up. I think we can see that. Can y'all see that? I can see that. And I'm going to pinch and get my midpoint. How come that doesn't look right? Let me fix this. B to C, right there. Well, I guess so. All right. And we're going to connect it to the opposite vertex, which is A. And yes, they intersect. So what we have here is we have three medians intersect, and I should have added some markings while we're doing that, but I forgot to label this one. This one, let's make that one P. Okay, so we have a median, and the way you know it's a median is you're just going to see tick marks on the side. So I'm going to put a tick mark to show M is the midpoint. I'm going to do 2 tick marks to show that O is the midpoint. And then I'm going to do 3 to show that P is the midpoint. And what we have here is we are showing the intersection, the point of concurrency. And for medians, when I have a point of concurrency, we have what we call a centroid. And it's also your point of the center of gravity. And I'll show a little animation of that. But let's go ahead and put an X right here. And so here's our construction showing the midpoint, the medians intersecting, And the way I know that is I see that we have 3 medians just having midpoints marked, and then the point of concurrency, the point of intersection of those 3 medians would be the centroid. So here, for your notes, we're going to take our construction and we're going to tape it or cut and paste it here till we have our illustration of that. But just understand, a median is a segment whose endpoints are a vertex of a triangle and the midpoint of the side opposite the vertex. And the centroid is your point of concurrency of the medians. And then the centroid of a triangle is, and I'm going to show you this in a simpler way, it is 2/3 the distance from a vertex to the median, or midpoint, so excuse me, of the opposite side of the vertex on the median. Meaning, okay, let's show you this real quick. What that means is, if I'm looking at point X, X is your centroid, and I was looking at the median BM, the distance from B to X would be 2/3, and the distance from M to X would be 1/3, because the whole thing would be 1, right? So the distance is 2/3 to that centroid. This is what the Centroid Theorem is stating. But an easier way to remember that, let's look at this. Do you see how they have the common denominator here? So really, the big one is always 2, and the smaller part is 1. So another way to look at it is that it's always going to be a 2-to-1 ratio. But this would be from the vertex. So I need you to make sure you have this construction and add that to your notes, and I'll check that tomorrow. Thanks.